And now we're going to go through part 2 of the factory training review for the 29. We'll mostly centered on operations, so we'll be going through the engine start procedure, some of the controls that are available on the helm for maneuvering and navigation, the VHF radio, anchoring, and then a number of maintenance items. The cabin helm station is well designed. All the necessary controls and instruments are readily at hand. And we'll go through all of these items in the next few slides. Before we actually start the engine, we'll open up the engine hatch and we'll take a look around and inspect for any leaks. We'll check the engine oil. There's that dipstick there with the red top. After you look at it, make sure that the oil's in between the max and minimum marks. And when you reseat it, make sure that you do hear an audible click when it goes in. Then look for that yellow sticky on the cap there, and if the engine's cold, because if it's hot, it's under pressure, so be careful. Anyway, when you open that up, you can verify that the coolant level is near the top of the expansion tank. While still down in the engine compartment, just take a look and verify that the seatcock is open so that we get good cooling water flowing through the engine. Okay, so we've closed the engine hatch. We've gone over to the battery switch section, and we've turned on the engine battery switch and moved now back into the helm station and in the main cabin. We've placed the throttles in neutral, and we'll use our EVC key fob to turn the ignition on the station. And then once that's done, then you can go over to the throttle, press the station button once there to activate that station, and then you can press the engine start button. When stopping the engine, you press the engine stop button on the EVC panel, and then push the ignition button until the green light goes out, and then wait 15 seconds before turning off the engine battery switches. Note, if you don't do that, if you turn off the battery switch without turning off the ignition button, you get an error message the next time you try and start up the engine saying that the control unit wasn't shut down correctly. Also, another point to note is don't turn off the engine while it's running at speed. You stop and you spot a whale and you decide you're immediately going to turn off the engine. The turbo may still be turning at high speeds, and with the engine off, it won't receive proper lubrication. When you turn on the EVC panel, the main throttle station is always activated, and you can tell that by looking at the top middle station button, and there'll be a green LED light there. If you wanted to activate a different station, you go to that station, make sure the throttles are in neutral, press the station button on that station. Also, if you wanted to lock out other stations, so you don't want the kids playing around on the command bridge while you're trying to operate from down below, if you press this button twice, it'll turn red and lock out the other stations. You can also verify that the throttles are neutral. There's a green LED on the side panel as well that shows that. There are several other buttons on the throttle. In the lower left, there's a low speed button, and that disengages the propeller every few revolutions and allows the boat to travel at slower speeds. And this is primarily for trolling purposes, for fishing. In the middle, there's a throttle only button. This disengages the propeller entirely. So the idea here would be if you're out trying to retrieve the anchor, or maybe setting out fenders, and you don't want anyone accidentally bumping the throttle, putting it in forward or reverse, you can press this button and prevent that from happening. On the upper right, there's a cruise control button, and if you press this, then it'll lock in the RPM setting, and then you can adjust it up or down by 50 RPM increments using some buttons on the front of the throttle unit. There are controls at both the command bridge and the cockpit station, and in order to activate those stations, then you just like at the main cabin helm, press that center station button, and as long as you haven't locked out the other stations, then that particular station will become active. Also, a good procedure before we start going is to do a steering wheel check at the dock, so verify that you've got smooth operation from lock to lock from every station without the steering feeling like it's skipping around during the turn, and making sure it stops firmly at the port and starboard at around 4 to 5 total turns. There is a 4-inch Volvo Penta display panel on the helm, and it can be used to show a variety of engine diagnostics, oil pressure, temperature, RPMs, etc. The 29 comes with bow and stern thrusters. The battery switches for each of those is located in the mid-berth. On the helm station, then there is a toggle switch that can be used to go left or right in each of those different thrusters. There's also a wireless remote that's attached to the panel, and that can be turned on and selected from the helm console. Here's a side view of the bow thruster and a close-up of the propeller inside that bow thruster tunnel. You can see the zinc there that's attached to it. The motor for the bow thruster is located under the master berth next to the air conditioning unit. This is a view of the stern thruster system. It also has a propeller with its own zinc internal to the canister. The battery for the thrusters is located in the starboard lazarette. Each of the thrusters has a shear pin that protects the motor if something's caught in the thruster prop. And if this pin shears, then the motor may sound almost normal, but doesn't produce any thrust. So the shear pin is held in place with a snap ring retainer. And then if you want to access the shear pin, if it needs to be changed, then it's got to remove the motor from its mounting plate and make sure that the power off is before you start doing that. The stern thruster motor can be accessed through this hatch in the cockpit. To remove the motor from its mount, first make sure the power is off, and then there's a ratcheting Allen key tool that's supplied with the boat that can be used to loosen the 2 bolts that hold the motor to its mounting plate. Ivan's tip is to loosen both of the bolts with the wrench, and then use your thumb and forefinger to unscrew and remove both of the bolts more or less simultaneously, and then your palm can support the motor and keeps it aligned evenly with the housing so it can be slipped off. There are 2 trim tabs on the 29. Those are controlled by switches that are located on the side of the helm armrest. They can be useful when trimming the boat from side to side if necessary because of weight distribution or as you're transitioning from low speeds to high speeds to raise the stern up. The 29 is steered with a rudder system. The rudder assembly is bolted to the stern, and then that is controlled by a hydraulic ram attached to an arm on the rudder, and then the hydraulics are controlled by the helm station, either the steering wheels or the autopilot. The 29's hydraulic steering is accomplished with self-venting helm pumps. The command bridge has a removable vent cap, but the 2 lower stations are sealed. You should only check fluid levels at the highest helm station. If you try and pop off the cap at one of the 2 or lower ones, then you'll have a big oil spill all over the place. When doing your pre-trip checks, you should be turning the wheels from lock to lock. It should take about 5 turns, and then resistance should be felt when you reach the lock. If there's air in the system or a hydraulic leak, then there won't be any resistance at that point. And so if needed, you can add hydraulic oil on the command bridge through that small access port. The 29 comes with a Garmin Autopilot system. The control panel for the system is located at the helm console as well as on the command bridge. When the system is engaged, the heading hold text will be green, and it'll show your intended heading, the heading it's attempting to hold, at the top, 150 degrees in this example. If you wanted to change that heading, you can either use the plus or minus 1 degrees or the plus or minus 10 degree buttons located in the lower section there. If you wanted to disengage the system, you just press the standby button and the heading hold text will gray out. Then you can say turn the boat to a new heading, for example 228 degrees, and then if you wanted to re-engage the system, in the lower left it reads engage, just press that button and the system will re-engage, holding the new heading. The Autopilot uses a separate hydraulic pump, and that pump is located in the starboard lazarette. That's an area that you should be kept clean and clear of loose items, and also occasionally inspect that area for any signs of hydraulic leakage. A short distance away from where the propeller shaft connects to the transmission is a stuffing box. And the next little section here is an excerpt from one of the Ezra-Prop turns spring maintenance sections that was conducted by Tim Bates.
Alright, so for our inboard boats, your boat has what's called a stuffing box or a packing gland. This is basically the seal from where the shaft goes through the hole, and it's what keeps that water tight. So, what is a stuffing box? The stuffing box houses basically a packing material which is used to seal the shaft going through the hole. It should be inspected and regularly tightened, so you always want to keep an eye on that and make sure that, number one, you don't have an excessive drip. It's not dripping too frequently, but you do want to see a drip. This should remain cool to the touch, so if it's overly tightened, you're probably too tight. If you're getting a lot of water in the bilge, you probably need to tighten it up. So this goes back to those rigid E110 offset X head wrenches that we talked about earlier, the 9.5 version. These two wrenches are what's going to allow you to tighten up that stuffing box. So on this slide we talk about how to adjust. So with one wrench you want to hold the stuffing box, which is the first one here. The stuffing box is the larger of the two, basically the adjustment nut. And then you want to loosen the locking nut, which is the back one here. So if you turn the locking nut towards the back of the boat while holding the adjustment nut here, that'll basically free these two from each other. With the locking nut loosened, you want to tighten or loosen that stuffing box until you achieve the right drip rate. So what you're looking for is a drip every 15 to 20 seconds while the engine is running and in idle gear. With the engine turned off, you shouldn't have a constant drip. If you're seeing a drip every 15 to 20 seconds with the engine not running, you probably need to tighten a little bit. To monitor the drip rate, you definitely want to have the shaft turning. So either do it at the dock with lines secure. I usually will go into forward idle and have somebody on the outside of the boat holding onto a bow rail. Make sure that the boat's going to rest nicely up against the side of the dock. Lines are tight. The other option would be underway. So if you're out away from the marina in an open area, calm water, you could always go into forward idle. Make sure you have somebody on lookout watching off the front of the boat. Once you have those adjusted properly, you can use a penetrating oil. You'll see on the picture here we have a little bit of kind of that bluish green look to this one. When they're new, they have a nice bronze brass look to them. Over time, as it gets salt water down there, you'll see that happen a little bit. It's purely cosmetic. It doesn't hurt the stuffing box at all. But if you wanted to keep it clean, you could always hit it with a brass wire brush, use a little bit of penetrating oil and a corrosion spray on it. Penetrating oil will also help loosen these nuts up. So if they're really tight, you can always spray those down with some penetrating oil before you go to adjust. So over on the right here, we have a picture of how to adjust. So if you're loosening the backing nut here, you just want to hold the adjustment nut in place while you turn the locking nut down to the right. This is facing, the right would be facing the aft side of the boat. The engine would be over here on the left. We just talked about loosening. So to tighten or loosen, and once you actually have the backing nut backed away from the adjustment nut, at this point you're either going to tighten to get less of a drip or loosen to get more of a drip. On the left here you have a picture of how to tighten. So once the locking nut is loosened several turns, you can turn the stuffing box or the adjustment nut clockwise towards the back of the boat until you get that drip rate that you're looking for. Make sure to basically retighten that locking nut once you get the correct drip rate, and then that's when you would want to monitor that drip rate with the engine running and in gear. You don't want to adjust this with the engine running and in gear, so I'll always turn the motor off, adjust the packing, and then once everything's back to tight, turn the motor back on and go into forward idle. If you've over tightened, so you look back there, the engine's running, you're in gear and you're getting no drip, at that point you would need to loosen a little bit. To loosen, you would once again loosen up the backing nut away from the adjustment nut, turn the stuffing box counterclockwise or towards the front of the boat, and then retighten up the locking nut and monitor that drip rate. So simply if you're trying to tighten, all you're doing is you're turning the locking, or I'm sorry, the adjustment nut towards the back of the boat. If you're trying to loosen, get more of a drip, you need to turn this larger adjustment nut towards the front of the boat. Are there any questions?
And that was Tim Bates going through his presentation on adjusting and loosening the stuffing box on the R-29. The 29 is equipped with an ICOM VHF radio, and this radio has AIS receive capability. So when you're traveling along, you'll see other transponder icons on your chart plotter indicating their position, speed, and other information. The Automatic Identification System, AIS, allows you to identify and track other vessels. It alerts you to the area traffic. Our chart plotter shows an AIS vessel as a green triangle, and the direction that the triangle is pointing indicates which direction the vessel is moving, the AIS vessel is moving. If the chart plotter thinks that the course that the AIS vessel and your vessel are on is a collision course, it'll turn that triangle red, draw a line, and put an X where it thinks that the two courses will intersect. When you click on the triangles, you'll get some information about each vessel, their location, their speed, heading, the name of the vessel usually, and some of the dimensions, length and breadth. So, as this is a new vessel, it's likely that your VHF does not yet have an MMSI number, but it is required to have that for VHF radios that have DSC calling requirements. And it is also a requirement when operating outside of U.S. waters to have an FCC number, issued number. So the process of doing that is to request your FCC registration number. If you've had a boat before, you probably already have this, but it can also be applied for using this website that you see here. Once you have your FRN, then you can complete a new application for ship station license using this second URL. And then once you log into that website, then you can see a tab that says apply for a new license. Just click on that and fill out the information such as your boat data basically. And then they will email your license and MMSI number to you. I say it can take up to 10 days, but it can usually much sooner than that. And then there are instructions in your manual for entering that MMSI number into the VHF radio. The Sonar transducer for the 29 is located inside the shower sump area. Users frequently set in a keel offset so that you have a digital number that represents the water depth under the lowest point on the boat. So in this particular example, the actual water depth that the sonar is reading is 26 feet, but with a 2.5 foot keel offset, the digital number that you see is 23.5 feet, so 2.5 feet less than 26. The sonar system is an in-hull transducer, so it sends its sonar signal through a solid fiberglass hull. The transducer sits in a cup filled with antifreeze. Because the acoustic properties of the antifreeze, the fiberglass hull, and the seawater are similar, the sonar signal can travel through the hull, down to the ocean bottom, and then back to this sensor with very little attenuation. If you do find that at some point the sonar isn't working as well as it used to, check the cup and make sure that it is full of antifreeze, and if needed, you can top that off. The 29 has a 145-gallon diesel fuel tank, and that feeds the engine, of course, the generator, and if installed, a Webasto diesel heater. When looking at the engine fuel diagnostics on the Garmin chart plotter, you'll have several measurements there. One is a calculated measurement. That's the 20 gallons seen in the upper right-hand picture. And that represents how much the Garmin thinks you've used. So it takes what you started with and subtracts how much has been used during the course of your trip and reports this result. In the lower gauge, the one that reads 21%, that's a mechanical filter that reads directly from a sender in the fuel tank. And the sender is located at a particular level, in this particular case at 2% fuel remaining, so that would be the lowest level of the cinder. The one additive that Ranger Tug and Volvo recommends is this Stanidine diesel fuel additive, and it has a number of features that they claim can produce some improvements, and so a number of people we know do use this. The Helm station has two Garmin 8612 chart plotters. Very handy to have these two systems. Typically, users will have a zoomed in detailed version of their position on one screen, and then either a zoomed out position on the other screen, or several of the other possible diagnostics, sonar, radar, etc., etc. In addition to having a sidebar that has a number of different display options, such as speed, miles per gallon, fuel flow, remaining fuel. There's also the pins section at the very lower section of the screen, so you can quickly go to things like your nav charts, your vessel settings, your autopilot, active captain displays, sonar, etc. The 29 comes with a Garmin 18-inch XHD radome with 4 kilowatt transmit power. The overlay component on the chart plotter is very useful for those occasional foggy days. For anchoring, the R-29 comes with 50 feet of chain, 200 feet of nylon line, a 22-pound claw anchor, and a Lumar windlass. The windlass has standard foot controls up down on the bow, as well as windlass control on the helm station. The windlass is centered in the bow area, and the chain locker is located just to the port side of that. There is a circuit breaker for this system, and it's located in the behind the mirror in the head in the main cabin. If required, this 5 amp fuse can be pulled in order to remove power from the windlass foot button solenoids. The 29 is equipped with a spotlight that's mounted on the forward mast pole. It has a panel that's located on the helm console, has the ability to turn it on and off and adjust its direction. Manuals for your engine maintenance and service protocols can be downloaded from the Volvo Penta website. Service intervals for different systems vary, but in general for engine oil and oil filters, the air filter, and fuel filter, it is every 200 hours. One of the do-it-yourself items is cleaning the seawater strainers. That's a fairly simple process. On the engine itself, there's a metal band that holds the strainer basket and cap on, and just release that. Then you can pull the strainer basket out and remove any of the debris, small bits of seaweed, etc. accumulate in there. When you put that basket back in, there's 2 pegs at the bottom of the bucket there that line up with 2 holes in the bottom of the strainer basket, so just line those up to make sure that you have it oriented correctly. Then you put the cap and the ring back on. And then the strainer for the air conditioning units and the other pumps, you can unscrew the cap on the top of that plastic lid. That allows you to pull out the strainer basket and inspect and clean that as well. Another maintenance item is to run fresh water through the various saltwater systems like our air conditioning units, the engine itself, the generator. So the process for doing that is to close the valve on the raw water seacock, and then you can open the seawater strainer and insert a freshwater hose in there and get it started, and then you can start up your device, and then you run that for several minutes while the fresh water runs through that system. There are 2 fuel filters on the engine that need to be changed at 200 hours or annually. A primary one, which is what's shown here, the big white canister with the T-top. There's a full description on that process as on the As the Prop Turns webinar on spring maintenance, part 1. So rather than repeat that here, I'll refer you to that video. This is the secondary fuel filter that filters out some fines in the system and also has the water and fuel sensor connected to it. Again, the As the Prop Turns webinar is got a full video description of this, and I'll refer people to that video rather than trying to repeat it here. The engine oil filters, and air filters need to be changed. And the air filter is located behind this clip, the box here on the side of the engine. And then there are 2 spin-off oil filters per engine. They do have different part numbers and different hole sizes, so make sure you get one of each. The 29 has 6 protective anodes. These are zinc components that are added to metallic systems that are in contact with water in order to prevent galvanic corrosion. 1 each on each of the thruster propellers. There's 1 each on the 2 trim tabs. Then there's a propeller zinc on the big propeller, and then a transom zinc that basically connects everything that doesn't have its own specific zinc, like the through holes. There are 2 bilge pumps in the engine compartment. They can also accumulate debris in the system, so that might be a maintenance item, is to occasionally check for those. And again, there's a really good description on how to take them apart and check those on the As the Prop Turns webinar that I've referred to before. The transmission system also has a dipstick where you can check the transmission oil. And the recommendation on the service protocol was that the oil and filters are changed after the initial use of 6 months or 25 hours, and then after that it's 200 hours or annual. This is the service protocol for the generator. They note that the oil change should be done after the first 30 to 50 hours of runtime, and then 100-hour intervals after that. This concludes the review of the systems and operations of the R-29, and we hope you have many fun adventures on your new Ranger Tug.